In both hard rock and coal mining, a process called roof bolting is used to prevent the ceiling, also called the back, from caving in. Long, roughly 2-inch diameter holes are drilled into the rock. A bolt is then inserted into the hole and secured typically with either an epoxy or concrete. This process is currently done with specialized roof bolting machines operated by miners. This procedure is somewhat dangerous since a miner needs to operate the roof bolting machines near unsupported rock.
Luckily, the process of roof bolting is often very formulaic and ready for automation. Our senior design team is working with a mines faculty research team funded by NIOSH and in collaboration with Komatsu to create an automated solution for roof bolting. Given the ultimate goal of making a fully autonomous roof bolter, the final design will need to run for longer than a single drill bit can last. Our team was tasked to design a proof of concept system that can exchange drill bits on a fixed steel continuously.
In the final system, the drill steels with spent bits will likely be held in a carousel similar to this one. While the steel is in one of these carousels, our system has to unscrew the bit from the drill steel, move it to a repository of spent bits, and install a new bit. These old bits can take a significant amount of torque to remove, so our system needed to be designed in a way that could deliver that torque. In order to move bits to and from the drill steel, we opted for a 2-axis linear gantry system driven by stepper motors. The x-axis is fairly standard, locking the gantry in the exact position when the motors are still. But for our z-axis, we opted for a semi-passive mechanism that can lift the payload up and over obstacles, but does not prevent the payload from moving upwards. This eliminates the need to perfectly match the height of the payload with the screwing and unscrewing motion of the drill bit on the drill steel.
To provide the high breakaway torque needed for removing spent bits, we incorporated an impact wrench into our design. The impact wrench turns an extension rod, which spins the gripping mechanism. The entire assembly is mounted on the Z gantry. In order to grip the drill bits, we opted for a 3-jaw scroll chuck for its self-centering gripping action and high grip strength. When the chuck is tight, custom jaws grip this necked portion of the bit. The chuck is operated by a DC motor, which stops when it reaches a target current draw. These systems are all controlled by an Arduino, which can be manually operated or continuously operated.
Our design effectively demonstrates a robust and highly adaptable system that exchanges bits on a fixed drill steel. The mechanisms used all have hydraulic or pneumatic equivalents that could make them suitable for mining, meaning our design is a useful insight into one possible solution for an autonomous bit-changing system. Thank you for watching, and thank you to our partners at Komatsu and to our sponsors NIOSH and the Mines Faculty Research Team, who invited us to work on this project. We look forward to demonstrating our prototype to you at this semester's Senior Design Expo.